Hi everyone, this is Mrs. Musoff. Today we're going to be learning about a new formula, and this formula is going to help us to find the sum of a certain number of terms of an arithmetic sequence. Remember, an arithmetic sequence is one where you add the same number every time. Alright, so like, for example, 2, 5, 8, 11, etc., because you're adding 3 every time. Alright, so we're going to start this off by thinking of a scenario. What would you do if someone offered you $1 million to tell them what the numbers 1 through 100 add up to? You only have 1 minute to do it and no cell phone to call a friend. What do? Well, doing this on your calculator would probably take you longer than a minute. So, hopefully, after today's lesson, you'll be able to use the sum of an arithmetic sequence formula. Alright, that's what this formula is right here. Okay, so if you ever have an arithmetic sequence, remember it has to be arithmetic, and you want to find the nth partial sum, which is the sum of the first n terms, we'll use this formula where S sub n equals n times the quantity plus an, all divided by 2. Alright, this formula is going to help us to calculate that sum. And some of these pieces we should already know, like we know a1 is always the first term. Alright, we know n is always the number term, so like the number spot. So the only new part is going to be this middle piece, which is a sub n right here. And it's not exactly new, but we look at it a little differently. A sub n is going to be the nth term or the last term. So for example, if I wanted the sum of the first 8 terms of the sequence, a sub n is going to be a sub 8, so the 8th term. Right? It's that last term in the sequence. Alright, because we're using a sub n, and sometimes you don't know the last term in a sequence, we're also going to be using our a sub n formula. Alright, so we're going to actually have to know 2 formulas for these problems. So let's try a couple examples so you can see kind of how it works. Alright, the directions say find the indicated partial sum for each arithmetic series. So we're telling you it's arithmetic, so you don't have to worry about checking. Alright, so first, for number 1, it's 4 plus 8 plus 12 plus 16 plus 20 plus ... So here, I know it's arithmetic. I'm just going to double check at what kind of arithmetic it is, like what the difference is. So I'm going to do the second number, 8, minus the first number, which is 4. And that's 4. And then I'll do it again just to double check. So 12 minus 8 is also 4. So D is going to equal 4 here. So yep, it is arithmetic. Alright, so to find S sub 9, we know that n is going to be this number here, the one that's with our sum, so n is going to be 9. It's the sum of the first 9 terms. And we know a sub 1, because a sub 1 is always my first term, so that'll be 4. Okay, but S sub n, we don't know, that's our formula, right? So I know some pieces. I'm just going to rewrite the formula down here so I don't have to keep scrolling. So this is the new S sub n formula. Divided by 2. Alright, I know 2 pieces of this. I know n is 9, and I know a sub 1 is 4. So the only thing left is to figure out what a sub n is, which I don't know. So right now I have S sub n is going to equal n, so 9 times 4 plus a sub n divided by 2. But, like we said, we don't know a sub n. Right? So that means we need to find it. So usually what I like to do is I like to split this up into kind of 2 sections. The first section is where I'm going to find a sub n, and that's using my a sub n formula. And then the second section is where I'm going to find S sub n using my sum formula. Alright, so the a sub n formula, you have it written down up above. I'm just going to rewrite it. Again, just so I don't have to keep scrolling. Okay, so the first thing is when we don't know what a sub n is, we're going to have to plug in the numbers we do know in order to find it. So here I know that a sub 1 is going to be 4. I know n is 9. This is all just straight from up here. And D, I already found, D is 4. And then I can type this into my calculator. Alright, so I'll pull up the calculator. Oops. So 4... plus parentheses 9 minus 1 times 4. Alright, and we get 36. So a sub n is going to be 36. But remember, that's not my final answer because I'm trying to find S sub n. So I'm going to take this number and use it in my S sub n formula. Alright, so S sub n will equal 9 times 4 plus, and now I know a sub n. A sub n is 36. All right, so it's just kind of a two-stepper for these sum formulas. And then once again, I'm going to throw it in my calculator. So 9 parentheses 4 plus 36 divided by 2. And that's 180. So my sum will be 180. All right, and technically it's S sub 9, so you could write S sub 9 for that also. All right, let's try it again in example 2. Okay, this one doesn't spell it out as much, so we're really going to have to work our magic here. Okay, find S sub 15. So remember, the 15, that is our n value, so n is 15. We also need to know A sub 1, the first term, and that's 40. The question is, what's A sub n? So once again, I'm going to split this up, and I'm going to find A sub n first, and then I'll use that to find S sub n. So remember, it's two different formulas we're using here, so make sure you keep track of them both. All right, the A sub n formula, I'll write it out for you, is A sub 1 plus n minus 1 times d. And the S sub n formula is n times A sub 1 plus A sub n divided by 2. All right, so I can plug almost all the information in here. The only extra piece I need is d, okay, which I can find from doing the second number minus the first. 30 minus 40, that's negative 10. And just double checking it, so 20 minus 30 is also negative 10. And you should be able to check it for all of them if you needed to, but they'll all give you negative 10. So now I can plug these in. So A sub n, or A sub 15, is going to equal 40 plus 15 minus 1 times negative 10. And I'm going to use extra parentheses because d is negative. All right, so let's type that in. 40 plus 15 minus 1 minus 1. There we go, times negative 10. All right, and we get negative 100. So now I'll use that in my sum formula. Okay, so sum, it's the sum of the first 15 terms. So I'll do 15 times 40 plus, and now it'll be negative 100. That's the number I just found. And I'll type that into my calculator as well. All right, so calculator, we've got 15 parentheses. What was it? 40 plus negative 100, or you could do minus 100, that works too, and divided by 2. And we get negative 450. So there's our 15th sum. All right. If you ever wanted to double check yourself, you could actually add these all together. So 40 plus 30 plus 20 plus 10 plus 0. You just need to find the next 1, 2, 3, 4, 5, the next 10 terms in order to do that, and that can take a while. So that's where the formula might come in handy. All right, there's one other kind of problem we might see, so let's go ahead and flip it over. Okay, and number 3, they give us that same sequence, negative 10 plus negative 5, well, not the same sequence, but they give us a similar sequence, negative 10 plus negative 5 plus 0 plus 5 plus 10 plus ... But this time they give you the last term, all right? That last term, that is A sub 10, all right? If n is 10, it's the A sub n term. So if they give you that last term, then when it comes to like splitting it up and finding A sub n first, and then finding S sub n, well, it's kind of like they're doing the first step for you. A sub n is that last term, so it would be 35. And that means when it comes time to finding S sub n, you already have that piece, so it's a little less work for you. Okay, you do still need to make sure you know the other pieces, so we need to know like n is going to be 10, and that comes from right there. And we need to know A sub 1 is negative 10. Okay, but I don't have to do that other step because now I can just plug it straight into my formula. So it'll be 10 and then times parentheses negative 10 plus 35, all divided by 2. And once again, I can type this in my calculator. You'll notice sometimes I'm using n here and sometimes I'm using the actual number. that depends on what your teacher prefers. So maybe double check with them. I don't mind which one, I don't care which one you use, but some teachers really want you to use this number. So if you're not sure, I would suggest putting a number there when possible. All right, so I'll type it in. Let's see, we got 10 times, what was it, negative 10 plus 35 divided by 2. So 125. And that'll be my 10th sum. Okay. Now, if you take a look at number 4, again, we don't always give you that number. So in number 4, there is no last term. So in that one, we would have to still do the effort of finding a sub n first and then finding s sub n. So it just depends on the problem. You have to pay attention to it. If you needed to, you could always find a sub n on your own. It's just that if they give it to you, we might as well save ourselves the trouble. Okay, so here, again, I know some information. I know n is 22. I know the first term is 34. I don't know a sub n, so I'm going to find it using my formula. And that means I need to know d, so I'm going to find d. 31 minus 34, that's negative 3. And just to double check, 28 minus 31, also negative 3. So I can find a sub n, or in this case, a sub 22. Okay, 34 plus, parentheses, 22 minus 1, times negative 3. And again, I would turn to my calculator to help me type some of this stuff in, because that's always helpful. So 34 plus 22 minus 1 times negative 3. Negative 29. And then I would use that to plug it into my s sub n formula. So s sub 22 is going to be n, so 22, times my first term, 34, plus that last term I just found, divided by 2. And again, we would type it into our calculator, and this time we should get 55 as our sum. Okay, pretty straightforward from there. So in number 5, your buddy claims it is impossible to add up all the integers from 1 to 100 in only 1 minute without your calculator or your cell phone. Do you think it's possible? And if it is, can you help him find it? Remember, this was the $1 million question in the beginning. So all the integers from 1 to 100, that's like the sequence 1 plus 2 plus 3 plus 4 plus etc. all the way up to 100. And you should notice that this is an arithmetic sequence because you're just adding 1 every time. Alright, so I know all of these. That means there are 100 terms, so n is 100. I know the first term is 1. I know the last term is 100. So I can just type this into, or plug this in my head into my formula. The 100th sum would be n, so 100, times 1 plus 100, divided by 2. Now, whether you can do that completely without your calculator, I don't know. These numbers are kind of big. But still, it can take you definitely less than a minute to do that. All right, and this should give you, let's see, 5,050. All right, so now you know how to find the sum of an arithmetic sequence. This is our 3rd formula that we've learned. So just make sure you know when to use it. And if you have any questions, ask your teacher. Thanks, bye.